Buckle up. Space is about to do that glorious mind-bending trick where the obvious unravels, and your brain politely asks for a refund because one of the strangest, most counterintuitive facts in planetary science is absolutely true. On Venus, a single rotation, a day, lasts longer than its entire orbit around the Sun, its year. It sounds like a glitch in a cosmic spreadsheet, but once you unpack the physics behind it, the solar system starts looking less like a neat family portrait and more like a chaotic riddle built on exceptions. Here's the headline version. Venus takes about 243 Earth days to rotate once on its axis, but only about 224.7 Earth days to complete one trip around the Sun. Venus finishes a year faster than it finishes turning around once. And if you measure a solar day on Venus, the time between one sunrise and the next, the bizarre math gets even stranger, shrinking that interval to about 116.75 Earth days, thanks to the way the planet spins backward and sluggishly. Pause here, because the natural reaction is, how is that even possible? How does a rock in space manage to take longer to spin once than to orbit the giant star it's circling? Start with the two signature oddities of Venus. It rotates extremely slowly, and it rotates in the opposite direction of most planets, a retrograde spin. If you were standing on the surface, ignoring the fact you'd be instantly crushed, melted, and dissolved, you'd see the sun rise in the west and set in the east. The planet is essentially doing a slow backwards pirouette that throws every intuitive assumption out the window. The reasons behind this aren't fully nailed down. Scientists suggest a combination of massive early collisions, long-term tidal interactions with the sun, and complex atmospheric torque that gradually stole angular momentum. In reality, it's probably a cocktail of all three. But whatever happened in the past, the present-day measurements are clear. Venus spins lazily, stubbornly, and in reverse. That backward spin is exactly why the solar day, sunrise to sunrise, clocks in so strangely. Because Venus rotates so slowly and orbits relatively quickly, and because it spins in the opposite direction of its orbit, the sun ends up crossing the sky faster than you'd expect from the 243-day sidereal rotation alone. The effect is so extreme that the solar day becomes shorter than the sidereal day, even though both are glacially slow by Earth standards. It's the kind of physics that makes your brain itch. A day lasting longer than a year, but a sunrise cycle shorter than the rotation. Even seasoned astronomers sometimes pause to rerun the math. But the real chaos begins when you consider the environment this bizarre spin rate exists in. Venus is wrapped in a monstrously thick atmosphere, mostly carbon dioxide, loaded with clouds of sulfuric acid. The surface pressure is about 92 to 93 times the pressure at Earth's sea level, and temperatures hover around 460 to 467 degrees Celsius, which is hot enough to melt lead with ease. The surface isn't just inhospitable, it is aggressively hostile. Soviet probes that managed to land in the 1970s and 1980s survived for barely an hour before being destroyed by the planet's pressure cooker conditions. That brutal atmosphere also explains why the long day and night cycles don't create enormous temperature swings the way they would on Earth. The atmosphere acts like a thermal blanket so dense and efficient that heat barely escapes. The planet cooks evenly, slowly, and relentlessly. Then there's the upper atmosphere, because Venus never settles for being normal in any layer. While the surface drags through its centuries-long rotation, the clouds above race around the planet at breakneck speed. This phenomenon, called superrotation, means the atmosphere can circle the entire planet in just a few Earth days, while the ground below barely budges. It's like standing on a rotating platform that takes months to turn, while a hurricane roars above you every few days. This dizzying difference between atmospheric movement and surface rotation is one of the biggest reasons Venus looks calm from afar, but behaves like a planetary fever dream up close. And then, the axial tilt adds its own twist. Venus is tilted by about 177 degrees, which effectively makes it upside down compared to Earth's orientation. But here's the nuance. That tilt doesn't create Earth-like seasons, because the thick atmosphere smooths out almost everything. The real story isn't seasonal change. It's the constant crushing furnace-like conditions created by the runaway greenhouse effect. The tilt matters mostly because it reinforces that nothing about Venus follows the clean, simple patterns we're used to. Stepping back from the numbers and weirdness, there's a bigger point. Venus is the ultimate cautionary tale for planetary science. Earth and Venus are nearly the same size, formed in similar regions of the solar system, and had similar starting ingredients. Yet one became a blue, life-hosting oasis, and the other became a hell world wrapped in acid clouds. Understanding why the two diverged so dramatically helps scientists decode the histories of rocky planets. Not just ours, but the thousands of exoplanets we're now discovering. If something as subtle as rotation rate, early collisions, or atmospheric evolution can completely alter a planet's destiny, then Venus becomes a cosmic warning label. Earth-like does not mean friendly. Now let's talk missions, because if Venus is fascinating, it's also frustrating. For decades, landing on Venus has been the ultimate hardware nightmare. The Soviet Venera program gave us our only surface photos, taken under conditions so extreme that modern electronics would last minutes. NASA's Magellan orbiter mapped the surface using radar in the early 1990s. But for years after that, Venus didn't get the same attention as Mars or the outer planets. That's changing dramatically. NASA has two major missions in development, Veritas and Da Vinci Plus, designed to probe the planet's geology, atmosphere, and history in groundbreaking detail. Europe's Envision orbiter will join them with its own arsenal of instruments, aiming to uncover how Venus's surface evolved and whether the planet ever had oceans. In short, Venus is back in the scientific spotlight, mostly because the questions it raises are too important to ignore. To help the weirdness hit home, imagine living on a world where sunrise happens once every 4 months. A single morning would last longer than an entire Earth season. Parties would have to be scheduled in 100-day chunks. A day shift would last 1/3 of a year. A night shift the same. And every step outside them in our hypothetical scenario where humans magically survive the atmosphere would reveal a sun that rises in the west and sets in the east like nature is playing a quiet prank. Or picture designing a robot for Venus. You wouldn't just need heat protection. You'd need a machine that can operate in crushing pressure, endure chemical corrosion, handle temperatures hotter than a grill, and still manage power over day-night cycles that stretch across months. Everything about the environment resists exploration. And yet the scientific payoff is enormous, because cracking the mysteries of Venus, its rotation, its atmosphere, its early water, its volcanic activity, helps explain what might happen when a planet takes one wrong turn early in its life. All of this loops back to the main cosmic mic drop. On Venus, a day is longer than a year. It's the kind of fact that feels like a trick question until you understand how deeply rotation, atmosphere, evolution, and history intertwine. Venus isn't just quirky. It's a reminder that the solar system isn't a symmetrical, predictable place. It's messy, dynamic, surprising, and sometimes downright rebellious. And Venus, slow-spinning, backward-turning, heat-soaked Venus, is one of the loudest examples. So, yes, space will never make simple sense. But that's the thrill. Venus stands there as the planetary embodiment of expect the unexpected, a world where your assumptions fail and the universe grins. It's the most dramatic proof that even next door in our own solar system, nature does whatever it wants. If this cosmic curveball blew your mind, don't stop here. Hit subscribe and dive deeper. More space oddities, wild planetary secrets, and universe-level plot twists are coming, and you won't want to miss the next one. The solar system is full of surprises. Let's decode the next mystery together.